So you probably learned about organic chemistry today in class and you're a little confused. Don't worry, I'm here to help. This video is part of a 4-part video series that covers 10.2 functional group chemistry. The videos are divided into alkane reactions, alkene reactions, alcohols, and substitution and condensation reactions. This video is going to cover alcohols. Alcohols go through two main reactions, combustion and oxidation. Combustion, I guess in a way you could argue that alcohols only go through oxidation because combustion is a form of oxidation. So combustions are a form of full oxidation. So the general concept of combustion is the exact same as the general concept that I explained in the alkane video. The alcohol reacting in an excess supply. Make sure that this is excess. And this basically means that there's enough oxygen for all of the alcohol to react. When there's an excess supply of oxygen, it's going to create two things, carbon dioxide and H2O. Don't confuse this with water. It's not water. Just think about it. When something is when you light alcohol on fire, you don't get water as a product. You get H2O in the form of gas. So remember that. Could be, a trick that saves your life. I don't know. But anyway, alcohols react with oxygen to create carbon dioxide or H2O. If this oxygen gas is not in excess, and there's not enough of it actually, there is a possibility that it could form carbon monoxide or just carbon in general with H2O coming along with it. This is the exact same concept as the alkane video. So if you want to go watch that, you can, but this is basically it. One thing to note for alcohols though, this is kind of a review back to 10.1. Remember when we named alcohols, we named them methanol, ethanol, propanol, butanol, pentanol, and so on and so forth. And this first part of the name basically represents how many carbons there are. So in this case, for example, this is methanol, and we know that there is one carbon only. This is pentanol, there's 5 carbons. And the reason why this is important is the way, when it goes up a series, I guess this is, in this way it's down, but when the number of carbons go up, the enthalpy change goes up as well. So I mean, obviously, I guess it's common sense. Combustion is an exothermic reaction. So it means combustion is going to release heat. And the amount of heat that is released depends on the number of carbons there are. And the reason is, when you use the exact same amount of a methanol, for example, which only has 1 carbon, it's going to create 2 moles of carbon dioxide. And more precisely, it's going to create a ratio of alcohol to carbon dioxide as 1:1. So if you use 2 methanol, then you're going to get 2 moles of carbon dioxide. But when we use pentanol and there's 5 carbons, the ratio is going to change. And so it's going to be a 1:5 ratio. So even if you use 2 moles of pentanol, the exact same amount as you did with methanol, it's going to create even more carbon dioxide. It's going to create 10 moles of carbon dioxide, which means the ratio goes up. The reason why there's more heat released is because more carbon dioxide is forming. So that's something that you should know. It's covered in the syllabus. So make sure you know that combustion is an exothermic reaction and that the degree of heat that is released depends on the order it is in the homologous series. Okay, let's go into oxidation. We tend to talk about combustion as a different type of reaction. I guess it's a very specific form of oxidation. In this case, we're going to talk about oxidation in general. And so we usually divide this into primary, secondary, and tertiary alcohols. Review to 10.1 again. The way they are named depends on the number of carbons that are attached to the carbon that is attached to the functional group. So in this case, this carbon is what's connected to the OH functional group, which means we're just looking at how many carbons is this carbon attached to, and the answer is 1. So it's a primary molecule. It's a primary alcohol. Same thing here. We're looking at this carbon. It's attached to 2 carbons, so it's secondary, and this is 3, so it's tertiary. So as a side note, before you move on to 10.2, make sure you're very strong in 10.1 in naming these alcohols because they get really important, that you're able to recognize things just by looking at their structure. I struggled so much more in 10.1 than I did in 10.2. And I struggled a little bit in the beginning of when I was learning 10.2 because I didn't have a strong foundation of 10.1. So make sure you review that a lot more than you do 10.2. 10.2 will come naturally. It's very concept based, I guess. There's not much if you're SL. If you're HL, there's a bit more that you have to learn. I'm not HL, so I don't care. This is just an SL video. Anyway, in oxidation, we use O in square brackets to represent an oxidizing agent. And in most cases, it's going to be in the form of potassium chromate, potassium dichromate. So that's K2Cr2O7. One thing you have to remember about this solution is that it initially starts off as orange. As it goes through the reaction, as it goes through the oxidation steps, it turns green. So the significance of this is that you can actually see the oxidation of alcohols as they change color. So when you put alcohol into this solution, it's going to turn from orange to green in most cases. So when you add a primary alcohol into an oxidizing agent, it's going to create initially an aldehyde. This is an aldehyde. And then when you leave that in the solution for even longer, it's going to go through even more oxidation. So there's like steps to this oxidation. It's going to oxidize this aldehyde into a carboxylic acid. And in this case, this would be the structure. If you're confused, like I said, review 10.1. It helps a lot. So yeah, the general concept is very simple. You add this primary alcohol into this oxidizing agent. It creates aldehydes. If you leave it in there for longer, it'll create carboxylic acid. If you want to stop the reaction at this point, you have to do something called distillation. You probably heard of distilled water, or you're probably already familiar with the concept of distillation. So I guess put very simply, the contraption generally looks like this. You have the solution here and you have heat applied from the bottom. It'll boil the solution, and because there's a difference between the boiling points of the two molecules, naturally one of them is going to boil before the other one will. And so it's going to boil off certain molecules and leave certain molecules, and then it's going to go through this. Basically, there's like a cooling chamber, and it's going to turn this gas back into liquid. So it's going to go from liquid to gas to back to liquid, and it's going to come out, and whatever is produced is the distilled solution. Looking at secondary alcohols, when it's oxidized, the same conditions. Oh, I should mention that usually it involves heat, so you need to apply heat in order for the alcohol to oxidize. So given the same conditions, the secondary alcohol is going to turn into what's called a ketone. Same principle, but when it's secondary, it forms a ketone instead of an aldehyde. There is no further stage. It does not oxidize any further. This is the final step. Easy to remember. What's even more easy to remember is that when there's a tertiary alcohol and it gets oxidized or it gets exposed to the same conditions, there's going to be no reaction. And so the reason why this is significant, the reason why we even study this in the first place, is to differentiate between primary, secondary, and tertiary. When we get an unknown alcohol and we expose it to the same conditions and there is no reaction, we can tell that the alcohol is going to be a tertiary alcohol. If it has a reaction, then we know that it's a primary or secondary alcohol. So that's kind of the significance. It's great for us students when we have to remember the processes. Tertiary has no reaction. Simple enough. So this is generally all that you need to know. They're the general concepts. Just remember that primary forms aldehydes and carboxylic acids. When you want to stop it, you have to distill the solution. Secondary will form ketones, and just remember that the entire solution is going to turn from orange to green when it's being oxidized. And the reason for that is because it forms Cr3 plus ions, and Cr3 plus ions are actually green. So yeah, pretty simple. Alcohols are not that hard. Don't get too confused from your textbooks and stuff. This is all you need to know in general. I may have missed a couple details, but if you know the general concept, those details will come to you naturally. So remember, combustion and oxidation. Combustion is a special form of oxidation, and then remember the general concepts involved in oxidation of a primary, secondary, and tertiary alcohol. If you're confused about these structures, review 10.1. I'm not going to explain these structures. They are explicitly kind of like a goal to be able to recognize these in 10.1. So review 10.1 if you're confused. If you have any other questions, you can leave it in the comments below. I will be answering every single one of them to the best of my abilities. I am a student myself, so I might not be able to answer the most deep questions, but within my reach of knowledge, I will try my best to help you. Anyway, I hope this video helped, and I hope it simplified the overall idea of alcohol reactions. Thank you for watching. If it helped you, give it a like, please. I make videos on IB chemistry, physics, and math, so if you need help, check out my channel. Anyway, I'll see you in the next video.